Hello kids, we are back to chapter 9 in our Bob Jones University Press Algebra 1 book, the second edition, and this is a fun chapter that we're getting ready to do. It is factoring polynomials. But before we get started, I want to ask you, do you know why the little boy threw his clock out the window? Well, I'm sure you do, it's an old joke. He wanted to see time fly. But what I need you to do now is I need you to stop, put down your pencil, and go outside and get all of the clocks that you threw outside into your yard because your mother needs those to be in the house, and it doesn't make your math lesson go any faster. But this one should be real straightforward. This is section 9.1, where we are going to be factoring common monomials. And I'm just going to read a little blurb here from page 364. It says, remember, multiplication, you begin with two factors, you multiply them together and you end up with a product. But factoring, however, you have your answer that you begin with. For example, you have your product, your binomial product. Actually, let's do this. And we can say that 30 is equal to 5 times 6. 5 times 6 is 30. You recognize this factor tree. And this is how we came up with our prime factorization of the number 30. 30 is equal to 2 times 3 times 5. These are the prime factors of a number. But these two factors right here, 5 times 6, also, when you multiply them together, result in a product of 30. So we're just going to take this process and expand on it a little bit with our algebra. For example, let's say that we have this trinomial given to us here. X squared plus 4x plus 4. You're going to be able to say, oh, I recognize that that is x plus 2 times x plus 2. And you'll learn all sorts of different ways to go from the product. This is your product, to factors. And you think, okay, how in the world, are you sure that's really what it is, Miss Betsy? Well, x times x is x squared. X times 2 is 2x. 2 times x is 2x, so you have x squared plus 4x. 2 times 2 is 4. So yes, this is the factored form of the trinomial, x squared plus 4x plus 4. Now, I don't want you to be afraid of this because it's really not a problem for you. You just learn it a little bit at a time. So what we're going to learn in here is we're going to find a common monomial factor, and it's sort of like doing the distributive property in reverse. There's a definition in the middle of page 364 that says a common monomial factor is a monomial that is a factor of all of the terms in the polynomial. So, let's go ahead and look at example number 1, which is, asks us to factor 8x squared minus 16. We have two terms here. We have the 8x squared and we have the negative 16. So first, what we want to do is take each term and factor it into primes, find the greatest common factor. So if we factor 8x squared, this is 2 cubed times x squared. If you need help with prime factoring, I don't remember if I did any where to tell you prime factoring that I've done, but you can find lots of prime factoring examples videos on the web. 16, when you prime factor that, it's 2 times 2 is 4 times 2 is 8 times 2 is 16. So 16 factored as a product of primes is 2 to the 4th. So you have to find now the greatest common factor of the 8 and the 16, GCF of 8, look at that, that's not an 8, is it? That's an X. GCF of 8 and 16. You have 2 cubed, 2 to the 4th. Each of these have a factor of 2 cubed in common. So the greatest common factor of 8 and 16 is 2 cubed. Then you also have this factor of x squared here, but there's no common factor involved because with 16, you don't have any x's. So your greatest common factor is 2 cubed, which is 8. Now let's see what we're going to do. We're going to factor out. We're doing the distributive property in reverse. So if we're doing the distributive property in reverse, we have something inside, and this outside area right here, this is going to be your greatest common factor. Your greatest common factor goes in the square. That work that we just did said that our greatest common factor was an 8. So if we say 8x squared divided by 8, we factor out an 8, that's x squared. 8 factored out of a negative 16, you have a minus 2 left. 8 times x squared is 8x squared. 8 times a negative 2 is a negative 16. And that's how you check it. So our factored form of 8x squared minus 16 is 8 times the quantity x squared minus 2. I only put this box around here to let you know that what you have outside of your parentheses is the greatest common factor. See how easy that is? You look at these terms, you see the largest factor they have in common, which was an 8. You factor that out. What do you have left when you take a factor of 8 out of 8x squared? You have x squared. What do you have left from a negative 16? When you factor out an 8, you have a negative 2. It's example 1. They have factoring common monomials from a polynomial. You have example step number 1, step number 2, step number 3 at the bottom of the page on 364. Make sure you understand how to do that. Now, let's go ahead and look at example number 2. I'm looking for my eraser. This is example number 2 on page 365. Example 2. You have we're being asked to factor 3x squared y minus 27xy plus 9xy cubed. Okay. What you're going to need to do is factor each of these terms and identify the greatest common factor with these terms. We're doing our distributive property in reverse. So we have something on the inside that has 3 terms, and we're going to have our greatest common factor out here. You look at our constant terms, we have a 3, a 27, and a 9. Well, the highest numerical factor that you can have in common is going to be 3. Is 3 a factor of 27? Yes. 27 is 3 cubed. 3 times 3 times 3. Is 3 a factor of 9? Yes. 3 squared is 9. So your greatest common factor is 3. Now, what other factors do we have in common? All of these bumped right up against each other. There are 3 factors, well, actually 4 factors, but we have a 3, xy, xy, xy. All of these 3 terms have factors of x and y in common. Now we have to figure out how many factors of x they have. Well, this is x squared, so there are 2 x's. X to the first, 1x. X to to the first, 1x. So all of these have one factor of x in common. What about the y? y cubed. Then the greatest number of y's that every one of these terms has, it's just 1. So our greatest common factor then is 3xy. Our greatest common factor sits in this outside place when we do our distributive property in reverse, 3xy. So when you remove factors of 3xy from 3x squared y, what do you have left? We simply have an x. And let me show you in a different way. We have, let me see how far down I can go. Can't go down very far. Let me erase our greatest common factor since we have already put it as 3xy. If we have 3x squared y divided by 3xy, cancel common factors, we have an x left. Now we have minus 27xy divided by 3xy. Let's see what common factors we have that we can cancel here. This is weird. It's making me wonder if I copied something incorrectly. No, I'm all right. We have a factor of 3 in common. Leaves us a 9 here. X's cancel, y's cancel. We have negative 9. It's the only factor left from that second term. Now, let's see what happens with our third term. 9xy cubed. When we factor out, or when we divide by xy, the x's cancel, the 3 goes away, becomes a factor of 3. 3y cubed divided by y is y squared, plus 3y squared. 3xy times the quantity x minus 9 plus 3y squared is the factored form of this trinomial here. Now I'm very deliberately, very consciously, very repeatedly reading these terms using the proper vocabulary. You say, well, Miss Betsy, that just doesn't make any sense to me. Well, what is 3xy times x? 3x times x is x squared. We have a factor of y. 3xy times negative 9, it's a minus sign. 3 times 9, 27xy. 3xy times a positive 3y squared. 3 times 3 plus 9, x, there's no x, y times y squared is y cubed. And you see that the problem that we began with, this product, doesn't look like a product because in our minds we're still stuck in arithmetic and thinking you can't have pluses and minuses in a product, but you can. Because this trinomial, the way that this was arrived at was by multiplying together a monomial and a trinomial. And look, 3x squared y, 3x squared y, minus 27xy, minus 27xy, plus 9xy cubed, plus 9xy cubed. That's how you do monomial factoring, factoring out a common monomial. Let me do example 3, 14a cubed plus 21a. Let's see, 14a cubed plus 21a. You look at this, and your mind at this point should already say 14 is 2 times 7, 21 is 3 times 7. So I'm going to have a factor of 7 in common. I've got an a cubed and an a. But let's just write this in factored form. Off to the side, but I'm going to write it directly down. 14a cubed, 2 times 7 times a cubed. Prime number, variable written with an exponent. 21a? 21a, 3 times 7 times a. Prime number, variable. What do you have in common here? You have 7 in common, and you have an a single term of a in common, which leaves you a squared. So what's our greatest common factor for these? 7 times a, or 7a. Our greatest common factor goes outside the parentheses. 7a. What's left when you take a 7a out of 14a cubed? 14a cubed divided by 7a is 2a squared. Remember when we did our prime factoring and we said that 14a cubed was 2 times 7 times a cubed? You have your greatest common factor. The factors that are left are what stay inside your parentheses. What did we say 21 was? What 21a was? We said that was 3, I almost wrote it too, 3 times 7 times a. Our greatest common factor is 7a. What factor do we have left? Plus 3. That's what stays inside the parentheses. Am I sure? Yeah, I'm sure. 7a times 2a, 7 times 2 is 14. A times a squared is a to the first, times a squared, you add the exponents. A cubed, 7 times 3 plus 21a. We multiply together our factored form. Has to agree with our original product. If it doesn't, clearly we've done something wrong. Let me do one example for you. More example. Let me do problem number 14. 2 pi x minus 4 pi r. 2 pi x minus 4 pi r. Now I believe I said that this was number 14. Yes, this is number 14 in your exercises. And I know that at least some of you are saying, can't do it, because it has Greek letters in it, has a couple different variables. Well, what do you do when you're factoring just a common monomial? Write each of these terms in their factored form. Well, it's really easy. 2 pi x, 2 times pi times x. Cannot break that down anymore. But 4 pi r, that's 2 times 2 times pi times r. Now we can look at these two, the factored forms of both of these terms. What factors do we have in common? Well, we have a factor of 2 in common, so that's part of the GCF. And we have a factor of pi in common, so that's another part of the GCF. Now, what's left? 2 pi x. We've already used 2 pi. X is the only factor left. We're subtracting. 4 pi r factored into 2 times pi times r. We've already used 2 pi. We have 2r remaining, which is just another way of saying 2 pi x divided by 2 pi gives me an x. 4 pi r divided by 2 pi gives me a 2r. And let's just go ahead and multiply this back to demonstrate to you. 2 times pi times x. And there's nothing there that goes together. So it's 2 pi x. 2 pi times a negative 2r. It's a minus. 2 times 2 is 4. Pi and r. Nothing else you can do with those. You began with this product here, 2 pi x minus 4 pi r. You factored it by pulling out the greatest common factor. Then we multiplied those two factors back together to verify that we could return to the original problem that we had. That's all that's involved in section 9.1. Enjoy these, don't make them harder than they are.